We're here to solve this TomTom puzzle by Murat Can Tonta. The theme is 2 of 0, and you see all these clues are 2s, 20s, 200s. Pretty elegant starting point, and the 200 draws my eye quickly. It's 2 times 10 times 10, which will equal 2 to the third times 5 to the second, and that means there'll always be 2 5s in these cages. And those are going to go in these cells. And this other 200 needs 2 5s in it, which look like this. The next thing we've got to do is get to the third represented, and we don't have an 8 in a puzzle that's 1 to 7, so we're going to need to have 2 times 4. So we actually can fully complete that group, and this 200 can't have 2, 2, 2 split apart, so it also needs to have a single 4 and then a single 2, and the remaining digit to be a valid product will have to be a single 1. So those look to be the ways to split out those cages. We should now transition to the 20s. 20s can sometimes be products. More often this grid looks like they're going to have to be sums because there are too many 20s, but this very small 20 in 2 cells has to be 4 times 5. And notice it works up above where the 5s are already in the first 2 columns in the top row and the bottom row. There's actually another thing. If you wanted to do a uniqueness trick, this digit has to be a 4. Because if it wasn't a 4, we'd have 2 answers here. So in a competition, I would certainly, seeing that this 4, 5, 4, 5 is a deadly pattern, I would certainly be marking that to be a speed solve. But we'll stick on the logical path for now. But it's always good to learn for those doing competition where you see uniqueness patterns, and this is an obvious uniqueness pattern on the left side of the grid. So marking the last 5s in these 2 columns and these 2 rows, we see that there's one more 20 that could potentially be a product, but the rest have to be sums, and the most constrained sum then is going to be the smallest one up here. Think about the fact the largest sum I can get in 2 cells is 6 and 7, which is 13. That leaves behind one more cell for a 7, which has to be the sum. We get where this corner cage, that's a value of 2, starts with a 1 and 3 in it. These will have to be a subtraction or division, and if it's a subtraction, these are the smaller numbers are being subtracted from something, so 6 minus 1 minus 3 is what that could be, and if it's a division, 6 divided by 1 divided by 3 is what it would be, so 6 for sure goes in the cell. With a 6 placed here, we said that a 20 could be this sum, but that's now eliminated, so this has to be a product for sure, and these 5s now get identified out. We get a 1-4 pair. Notice that tied to the 1-3 pair up above, the 1s are now already used in this column, so we'll be able to use that pretty quickly. I think what it means is that we have a challenge to place a big digit like a 7. 7 with 5 is no longer possible, so 7's not down here, so 7 is up here, and that means we're going to have a 2, and it can't have another 1 because the 1 is already taken up above, so it's going to be with a 4. And that's going to force these values across. And note that to the left is another 4 already in that bottommost row, so this is how this has to shape. 7 in a 2 value cage with 3 cells is going to be a subtraction. 7 minus 2 minus 3 is the only option left because 1 and 4 up above. 7 minus 5 is 2, and a 6 is in this bottommost space. We have some more work to do, I think, on the bottom. One thing I'm seeing is as I place more digits, I'm just looking for the rest of them. And so I've got 4 7s placed, so let's look at where the last 7s go. 7 can be in those 3 cells, or in this bottommost row only in this space. So I think the most useful thing about looking at the 7s is I get 2 digits placed in this 20 cage. They sum up to 14. What that means is now the remaining digits in this space are probably going to be 1, 2, and 3. Particularly after I place this 1 or 3 in, I'm leaving behind a sum that's going to be 1, 2, and 3 with the 4 over there. So 6 is nowhere near this 20 cage is the takeaway. So 6 isn't in these 3 cells on the left. 6 can't be in this cell for a few reasons. It also can't get to the value of 2, but a 6 is up above. So there's a 6 right here, which will help us out. 6 in this cage is a 1 with a 3. We had that also in the upper right corner. There needs to be a 4 and a 2. In the space, we now have a sum of 12. In this cage, it gets up to 20, so we have 8 more in these 2 cells. 3 with 5 isn't possible anymore. 7 with 1 isn't possible anymore, but 6 and 2 is, and that's going to be forced in the grid for sure. This 2 is going to come up top and eliminate the 2s from those cells, put a 2 here, which actually completes a lot of the space. The 1, 4 coming down, put a 3 in, put a 1 in, put a 3 in. We're now going to have 1, 2, 7 in the space, the 2 7s on the left. This is a single spot for the 1, get a 3 up top. We're going to have a case where we've got to figure out how to make this bent 2 cell work well. Notice that with 3 already in it, if a 7 were here, it really wants to be with a 2. That's the only way subtraction works. So looks like it's got to be with a 6, and it also has to be a 1 down below, so that finishes out these values. We'll just play some ping pong here. We got a 7, so we're going to look at our note. We place a 7, which gives us a 2. We place a 2, gives us a 5, so we place another 5, gives us a 4. We've got to figure out where a 4 goes, but let's come now and just play ping pong in the columns. So we have a 1, 6 to place here, and there's a 6 on the right, so we place a 6, which forces a 1, forces a 1, place a 4, forces a 4, place a 3, forces a 3, and then place a 2. And so this sense of keep a digit in mind for the next spot, switch to the partner, find the next of that partner, just keep going. This is the way the end of Sudoku puzzles, TomTom puzzles, other Latin square puzzles tend to go. So hopefully you got a sense of how to work through this TomTom. Really elegant puzzle from Murat. A lot of great use of the 2 and 0 clues, mix of products multiplications, and then just some speed tricks. I showed, for instance, the uniqueness in the top is one kind of speed trick, and some others came through the video. So hope you learned something from this solve, and we'll see you again soon.